my name is Aya, and I am a PhD student in the transportation group, specifically the Intelligent Transportation Systems group with Professor Bahir Abdul Hai. So now we are on the campus of U of T, and we are in front of the Stanford Fleming building where the group of transportation resides, basically. Generally, my research is in transportation economics and demand management policies. My PhD research topic in specific is about congestion pricing, which is basically charging drivers for using certain roads for specific time periods, mainly to tackle traffic congestion, to reduce demand, and to distribute it more evenly over time and space.
This graph shows traffic flow by time of day, where these are the rush hours. Now imagine that price is tied to traffic flow. So when traffic flow shoots up at rush hour, price rises too. And when traffic flow falls, price falls. That system is called congestion pricing. To see it work, we'll overlay price here. Raising and lowering the price pumps traffic up and down. So if we raise the price at rush hour and lower it at other times, then we'll smooth out traffic flow.
So as you may know, there is a wide discussion currently going on whether congestion pricing or tolling roads and highways is a potential source of revenues and a potential policy to manage demand. So I guess our research is should provide like a good quantitative assessment of this policy that should help stakeholders in general and policy makers in specific to decide the effectiveness of such congestion pricing policies in the GTHA, the Greater Toronto and Hamilton area. So I did my undergrad in Cairo University in Egypt, and my bachelor degree was from Communications and Electronics department. And then I did my master's also in Cairo University in Mathematical Engineering. And then I came here for my PhD in transportation. Within the transportation community, I'm involved in Institute of Transportation Engineers, and also there is one called the City Center Graduate Association. And outside campus, I'm involved within some extracurricular activities, and a member of the Egyptian Student Association in Toronto and in North America. Actually, I come from mathematics and communications background, which is pretty theoretical. So what's interesting in my current research is applying those models that I have been working on for years in a field like transportation, which is very realistic, practical in everyday life. So it's very interesting to apply the models that I worked on before on practical applications and practical side of life. Well, so I've taken many courses, but the most ones related to my research are transportation planning, urban operation research, transportation economics. I also take a specific course in road pricing and also demand analysis. Those 4 or 5 were the most relevant to my current research. We are using we have some main modules in our research. So we have optimization algorithms. We have a genetic algorithm cluster here at U of T, developed and used by many students before, and it's a robust one, and it's working on a parallel cluster. And also we have another module which is discrete choice models, some models that were developed already here at U of T, and we are working on extending them to include some other aspects. So basically we test the impact of tolling on drivers' behavior. Also the third module is simulations. So we are using a mesoscopic simulation, and we are getting the demand from the data available here at U of T through the TTS survey, Toronto Tomorrow survey, which is a survey conducted every 5 years on around 5% of the GTA population. So those are basically the 3 basic modules in our research. As you see in this flow chart, we have mainly 3 modules in our framework. So we have the first one is an optimization algorithm, the second one is a discrete choice module, and the third one is a traffic network simulator. So in brief, our framework is mainly an iterative procedure to come out with an optimum toll schedule over the links under consideration in the network. And in this procedure, we will be taking into account the discrete choice behavior of people, the disaggregate behavior of individuals in terms of mode choice and departure time choice impacts of tolling. And finally, we'll be testing and assessing that through a mesoscopic simulator to get the impact of such policies on the network, travel times, and travel costs, and so on. And the procedure is iterative until we get to a convergence and equilibrium state in terms of choices, in terms of tolling structures, and so on. Basically, we are currently working on some test scenarios in the GTHA, which is the Greater Toronto and Hamilton area. So we are testing our algorithm on freeways, hot lanes on the Gardner Expressway, and also a freeway corridor, so having the Gardner tolled in the lakeshore for free, and also a cordon network. And as you see, we are using a mesoscopic simulator. So basically, our test areas are in Toronto. However, we are assessing the impacts on the entire GTHA. The area is connected, so we are trying to assess the impacts on the entire area. Looking into the future, I wish we can get what we are working on now into the stage of being implemented and solving congestion problems in the GTHA. It's not only about having numbers and graphs. We need to get that to implementation stage and policy stage.